what I do is I tend to use a pattern, and that's exactly what EngageNY is using as well. So let's start with something like 3 times 4. So this, we're going to define this as 3 groups of 4. So you've got 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and so we can see that 3 groups of 4 is equal to 12, and if we wanted to, we could write that as 12 divided by 4 equals 3. All right, so there we go. 12 divided by 4 equals 3. Now we can change that to 2 groups of 4. All right, 2 groups of 4 equals 1, 2, 3, 4, 1, 2, 3, 4, and 2 groups of 4 equals 8. And we can change that into a division problem by writing 8 divided by 4 equals 2. And then lastly, we could do 1 group of 4, which looks like 1, 2, 3, 4. So 1 group of 4 is equal to 4. And if we were to write that as a division problem, we'd have 4 divided by 4 is equal to 1. So we can see the beginnings of the concept of, well, any number divided by itself is going to equal 1. All right? Because we could repeat this with groups of 5 or groups of 6. Now, using this same pattern, we could take the division problems over here and we can change them slightly using this same multiplication scenario. We can change it to 12 divided by 3 equals 4. And we can change this to 8 divided by 2 equals 4. And then similarly, we can change this to 4 divided by 1 equals 4. And so down here, this one is the beginnings of the rule that any number divided by 1 is itself, because we could repeat this process using 5 in each dot in each group, in which case we would have ended up with 5 divided by 1 equals 5. All right, so this same multiplication scenario leads us to 2 discoveries about division. One, if you divide a number by itself, you get 1. And then the other, if you divide a number by 1, you get itself. So let's do a little bit of practice here. It says let C equal 8, and then determine whether the equations are true or false. So for this first one here, we're going to change that to 8 times 0 equals 8. All right, well, 8 times 0 equaling 8, that's a false statement, so that's why they wrote the word false over here. So let's try the next one. 0 times 8 is equal to 0. Well, that's a true statement. And then we've got 8 times 1 equaling 8. Well, that's a true statement. How about 1 times 8 equaling 8? Well, that's a true statement. How about 0 divided by 8 equaling 8? Uh-oh. That's not a true statement. That's a false statement, because really 0 divided by 8 should be 0, not 8. And then 8 divided by 8 is equal to 1. That's a true statement. And then we have 0 divided by 8 equaling 0. Yeah, that's a true statement. And then lastly, 8 divided by 0 equaling 8. Now this might be a little bit of a controversy here. So teachers, this answer, by the way, of course, is false. And this is going to be a real argument here. And we have to explain why. Why is this a false statement? Why isn't 8 divided by 0 8? Or maybe, big question mark, or maybe students might think that 8 divided by 0 should be 0. And so we have to explain to our students why you are never, ever, ever allowed to divide by 0. That's going to be on the next slide. So we have to explain why you're never allowed to divide by 0. And so we're going to do that through some examples. So 12 divided by 3, and I'm just making that problem up. 12 divided by 3 equals 4. How do we know? Because we know 4 times 3 equals 12. All right? Now what if I did, let's do 18 divided by 2. 18 divided by 2 equals 9. Why? Because 9 times 2 equals 18. All right, so the idea is whatever you think the division problem is, you can always check it by multiplying. All right, so we're going to take that idea, and now let's do, over here, let's do, and I'm going to do it in blue, let's do 8 divided by 0. What could it be? Well, let's say maybe 8 divided by 0 is equal to 0. All right, well, that would be because, now, if I wanted to, we're going to follow this pattern over here. 12 divided by 3 equals 4 because 4 times 3 equals 12. All right? So if we think 8 divided by 0 is 0, that would be because 0 times 0 equals 8. Oh no, that doesn't work. And since 0 times 0 is not 8, that's not true. That means our idea of the answer being 0 is wrong. So I'm going to put that in big old red X. That's wrong. So let's try another one. Well, maybe 8 divided by 0 is equal to 8. Well, that would be because, if that's true, it would be because 8 times 0 is equal to 8. Because if 8 divided by 0 equals 8, then 8 times 0 equals 8. And is 8 times 0 8? No. 8 times 0 is 0. And we know that's wrong. So that's wrong. So the idea would be if whatever 8 divided by 0, 8 divided by 0 equals something. So basically they're saying, that means something, something times 0 has to equal 8. Well, that's impossible. You can't do something times 0 to equal 8. There is nothing times 0 that will equal 8 because 0, when you multiply by 0, you always get 0. You can never get 8. So that's why you're never ever allowed to divide by 0. This is called, it's called the Null Set, or sometimes we say null, or sometimes we use these, that's an ugly one, these brackets, these empty brackets. But the idea is 8 divided by 0 is impossible. You're not allowed, there is no answer for 8 divided by 0. So let's do a little bit of practice. Rajan says that any number multiplied by 1 equals that number. And we're supposed to write a multiplication equation using n. So he said n times 1 equals n. Any number, that would be n, multiplied, that's the x, by 1, that's the 1, equals that number, n. So there's our equation that Rajan came up with. N times 1 equals n. Now it says, using your equation, let n equal 5 and draw a picture to show that the new equation is true. So let's see. We're going to start off with n times 1 equals n, but then we're going to turn it into 5 times 1 equals 5. And we're supposed to draw a picture. A couple of ways we could do it. We could either think of this as 5 groups of 1, or we could think of this as one group of 5. In either way, we can show that the answer is indeed 5. Let's do 5 groups of 1. So 1, 2, 3, 4, 5. 5 groups of 1, 1, 1, 1, 1, and sure enough, 5 groups of 1 is 5. Another way we could have called it is we could have said it was one group of 5. Using the commutative property, we could have said one group of 5 like this, and in which case it would be one group with 5 in it. And in either case, it shows that the equation is true. And that is Grade 3, Module 3, Lesson 16, where we're talking about multiplying and dividing involving 0 and 1.